Okay, so this video's topic is going to be all about triangles and trying to prove that they are congruent, or at least figuring out why they're congruent. We're not necessarily going to prove that they're congruent right now. So you've been watching the last videos. We've been talking about Euclid, the father of geometry, and how he had been recently looking into the idea of figures being congruent. And what he figured out and what you saw in the last video was that in order for two figures to be congruent, all of their corresponding parts have to be congruent. Which means that for triangles, that means there's 6 different things that you got to show are congruent. All 3 sides, all 3 angles. That's a lot of stuff. And so Euclid was determined to figure out how to prove that 2 triangles are congruent in a more efficient manner. And he discovered 5 different ways of proving that triangles were congruent that are essentially shortcuts. And so the first way that he figured out was called SSS postulate, or side-side-side postulate. And that says that if 3 sides of one triangle are congruent to the 3 sides of another triangle, then the triangles are congruent. So that's going to look like this. So if we've got a triangle like that, with all 3 of those sides being congruent to all 3 of these sides, that is a side, and a side. So that is side-side-side postulate. The next method, very similar, said that if 2 sides and the included angle, and by included I mean the angle right in between them, are congruent to 2 sides and the included angle of another triangle, then the triangles are congruent. So that looks like this, where there's 2 sides that are marked and the angle right in between them, the included angle. That's side, angle, side, or SAS. Our next one's kind of the flipped version of SAS. It's ASA. It says if 2 angles and the included side are congruent to 2 angles and the included side, then the triangles are congruent. So that would look like this. 2 angles with the side in between. 2 angles with the side in between. So that is ASA. Angle, side, angle. Our next one is very similar to that last one. It says if 2 angles and the non-included side are congruent to 2 angles and the non-included side, then the triangles are congruent. And you might have noticed that this one's actually a theorem, not a postulate. That's because Euclid did actually prove this as an extension of the ASA postulate. And so you're going to notice that the way that I marked those has these 2 angles and the side that's not directly in between them. That's the meaning of non-included. So this one looks very similar to the last one. It's just that the side is not directly in between the 2 angles. Then we've got the HL theorem. The HL theorem says if a leg and a hypotenuse of a right triangle are congruent to the leg and the hypotenuse of another right triangle, then the triangles are congruent. So this theorem works for right triangles and only right triangles. So it says if you've got 2 right triangles with a leg and the hypotenuse, remember a leg is one of the sides that makes the right triangle or makes the right angle, and the hypotenuse is the side that's opposite the right angle. So we've got a leg and the hypotenuse. That gives us HL. Then there's a few methods that just don't work. You probably noticed that all of these methods require 3 things, right? Like a side, a side, a side, a side, an angle, a side, or a right angle, a leg, and a hypotenuse. But not all combinations of 3 things work. For instance, side, side, angle, and angle, angle, angle are both not valid reasons for triangles to be congruent. So that would look like this. If I've got a side in an angle, that doesn't work. Or just an angle, and an angle. So neither of those methods are going to work. And just to reiterate, previously when we were talking about congruent figures, we said that in order for congruent figures to be congruent, all 6 of their parts needed to be matching. But all of these methods only require 3 things. So they're twice as fast for proving that triangles are congruent. Okay, so how are we going to do this? How are we going to find these 3 congruent things to figure out why these triangles are congruent? Well, there's certain things that we've already learned that are going to help us. So this says when determining why 2 triangles may or may not be congruent, it's always important to be on the lookout for reflexive sides, angles, and vertical angles. Now, what's a reflexive side? A reflexive side is a side that 2 figures share. It's always congruent to itself. So when we're going to be on the lookout for these 3 congruent things, one thing that we can always mark is called the reflexive side. And what we just said is that it's a side that 2 figures share. So if we see these 2 triangles sharing that side in the middle, we get to mark it. That's going to count as one of our congruent things. One of our 3 congruent things we need to find. A reflexive angle is very similar. It is an angle that 2 figures share. So if I've got maybe something like this. If I've got these 2 triangles, so like if I've got yellow triangle here and blue triangle here, you're going to notice that up at the top, they both share this angle. That is a reflexive angle. That is an angle that they both share, and it's always going to be congruent to itself. So we get to mark that if we see it. And then we got vertical angles. Vertical angles, we've seen this since the very beginning. Vertical angles are opposite angles formed by intersecting lines. And vertical angles are always congruent to each other. So if we've got some intersecting lines, these vertical angles, we always get to mark them. They count as one of our 3 congruent things. So our goal, we're on the lookout for 3 congruent things. If we can find 3 congruent things between these 2 triangles, then we can use those things to figure out if it's going to be side, 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 angle, one of those things. And sometimes we're not going to be able to see 3 congruent things right away. And if we don't see 3 congruent things right away, let's be on the lookout for any of these things that we just saw. Reflexive sides, vertical angles, that kind of stuff. So down here, it says mark the diagrams, complete the congruency statement, and determine which method of triangle congruence should be used. Let's look at this first one here. Looking at these 2 triangles, triangle JKM, triangle LKM. Looking at those 2 triangles only have 2 things that are marked on them, right? And we need 3 things. But hopefully you recognize those triangles share this side in the middle. That is a reflexive side, right? So I'm going to make a note. That's a reflexive side. We get to mark that. That gives us our 3 things that are marked. And to complete the congruency statement, triangle JKM, that would match up with LKM by following the markings, right? JK matches LK, KM matches KM. So JKM congruent to LKM by side, 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 right? Because I've got 3 sides that are marked. All right, looking over here, looking at triangle ABC. I only see 2 things marked on these triangles, But what about the vertical angles, right? Vertical angles we get to mark. Those are always congruent to each other. That's going to give me my 3 congruent things. And I can see now I've got an angle, a side, and an angle with that side directly in between. So let's complete the congruency statement. A, B, C congruent to, well, A goes with D, B would go with E, and C goes with C. And like we said, angle, side, angle. We'll make a little mark. We got to mark those vertical angles. Going down here. Looking down here, right away, those triangles only have 2 things marked, but I see this reflexive side. So that's going to give me my 3 congruent things. Triangle ABD. Well, A matches C, so triangle CDB. And this one, I've got a leg and a hypotenuse. This is HL. HL is sometimes a tricky one. Just remember HL. HL only works with right triangles. So if you got a right triangle, you should be thinking about HL. Not every right triangle is going to be HL. But it's a good one to remember. Okay, and then this one, right away, I notice our reflexive side in the middle, so I'm going to mark that. And then looking at our markings, I see an angle, and a side. So triangle DCB would be congruent to triangle DAB, making sure that I line up the letters the right way. And that would be angle, side. Now, just one more time, important to remember the difference between angle, side, angle, and angle, side. Remember, it's the difference between where the side is. We can see it really clearly in these 2 that we just did. The top one, we have the side in between the 2 angles. The bottom one, the side is outside the 2 angles. So that's the difference between angle, side, angle, and angle, side. Okay, so we're going to step it up a little bit more here. This says, don't forget about midpoints, different angle pairs formed by parallel lines crossed by a transversal, and the different special segments and triangles. These are all other things that we have learned in previous videos that are going to help us mark more things on our triangles. Just different things that we know are going to be congruent. So once again, to reiterate our goal is to find 3 congruent things and use those congruencies to determine if it's going to be side angle side or HL or angle side angle, right? We need to find 3 congruent things and then we can determine it. Okay, so in this one, right away, those 2 triangles, I have 1 congruent thing. Just side AB being congruent to side DC. But I notice my reflexive side, that's a 2nd congruent thing. And I need 1 more. And so that's going to be the reason why we have these parallel lines. We have those arrows. Arrows mean that things are parallel. If I was to imagine extending these lines a little bit and extending this transversal, you might notice that I've got some alternate interior angles. This is a new thing. We haven't seen this in an example yet. So I'm going to label it. But that's our 3rd congruent thing. Okay, since we have those parallel lines, that means those alternate interior angles must be congruent. If you see arrows, if you see parallel lines, think about alternate interior angles. Okay, that's 9 times out of 10 the clue that they're trying to give you. That gives us our third set of congruent things. And now we see that we have a side, an angle, and a side between those two triangles. So triangle ABD would be congruent to triangle CDB by side, angle, side. Okay, our next one over here. We've only got one congruent thing right away, just side AB being congruent to side DE. But hopefully you see our good friends, the vertical angles, right? That's one free thing we can get. So now we have two sets of congruent things. And then once again, we have these arrows. These are my parallel lines. And if I'm using this as my big transversal, then I would have angle A and angle E being congruent, because those, once again, just like the last one, are alternate interior angles. That's going to give me an angle, and a side. So I can say triangle ABC is congruent to triangle DEA by angle, side. Okay. What about this one? Okay, so right away I see only one congruent thing, but hopefully you recognize the reflexive side in the middle. Get to mark that. Oh, and then it says KM is an angle bisector. Well, if KM is an angle bisector, that means that this big angle up top is getting split in half. So that's going to give us our third congruent thing, right? That's what an angle bisector does. It splits things in half. So that's going to give me side, angle, side. So triangle JKM congruent to triangle LKM by side, angle, side. All right. Then this one. What do we got going on here? We got some arrows. Okay, so right now we've got one thing that's congruent, just those right angles. But we do have a side in the middle. We get to mark that. So that's two congruent things. And now let's think about some parallel lines again. We've seen a lot of them on these ones. If we've got some parallel lines because of those arrows, that means that these alternate interior angles got to be congruent. That's going to give us our third congruent thing. So now if I'm looking at my stuff, I've got an angle, and a side. So triangle ABD would be congruent to triangle CDB by angle, side. Okay. What's going on with this one? So right now I only see one congruent thing, angle A and angle D, but we know about our vertical angles. We always get to use those. And then it also says that C is the midpoint of AE. And if C is the midpoint of AE, that means AC's got to be congruent to CE. So that gives us our third congruent thing. So now I can say triangle ABC congruent to A is marked the same as D. So DEC by angle, side, angle. Okay, and then on this one, ooh, we got nothing marked. Goodness, we need to find three congruent things. Well, one right away, they share that side. So we get to mark that. And then it also says KM is the perpendicular bisector of JL. Well, if you remember your special segments, perpendicular bisectors do two things. They make right angles, so that's one other congruent thing. And then they also bisect the side. So that means that those have to be the same. So that's our three congruent things. JKM would be congruent to LKM. And the reason would be side, angle, side. Okay, now one important thing before you start trying some. These facts, the vertical angles and the reflexive sides, you get to use whenever. Okay? If they share a side, you get to mark it. If you see vertical angles, you get to mark it. The stuff we added over here, the alternate interior angles, the angle bisectors, the midpoints, the perpendicular bisectors, you only get to use if they tell you lines are parallel or if they tell you about a midpoint or a perpendicular bisector or anything. You do not get to assume that something is a midpoint. You do not get to assume that lines are parallel. You do not get to assume that something's a perpendicular bisector. Okay? You can only do that if they're talking about it. These things, the reflexive sides, the vertical angles, you do get to assume. Those are safe to use whenever you see them, because that's just based on the diagram. And those things aren't going to lie to you. But sometimes things might look like they're a midpoint, but they don't say it's a midpoint, you don't get to use it. If things look like parallel, but they don't say they're parallel, if you don't see those arrows, you don't get to use them. Okay, so be careful there. Don't get too gung-ho. All right, so your turn to try some things. Same deal here. You've got some parallel lines, it looks like. You got some arrows, you got some other special stuff. So try to find those three congruent things and then determine which method to use. Then come back to the video after you try them. Okay, so this first one should have marked the reflexive side. And then you got two sets of parallel lines. This is kind of wild. So for the first one, if this is parallel to this, using this as our transversal, you should have marked these alternate interior angles. But then also, if the blue line's parallel to the blue line, then using the blue with the green, we get this set of alternate interior angles. So this ends up being an angle side angle. I would say ABD is congruent to triangle CDB by angle side angle. All right, if KM is an altitude here, then that means these are right angles. Also, we've got the reflexive side in the middle. So triangle JKM congruent to LKM, and this would be by HL. On this one, we get to mark the reflexive side in the middle. And then if this is parallel to this, with this being our transversal, we would get to mark these alternate interior angles. And actually what ends up happening on this one, this was a tricky one that we put in here. This is a side-side angle. And side-side angle doesn't work. These ones are just not congruent. Tricky. Triangles are not congruent on that one. This one, well, I got some vertical angles I got to mark. And then if C is the midpoint of DB, that means that DC is congruent to BC. So triangle ABC is congruent to triangle EDC by side angle side. Just to label it, side angle side. All right, KM is a medium here. Well, we get the reflexive side in the middle, and then if that's a median, that bisects the opposite side. So JM is congruent to ML. So JKM congruent to LKM by side, side, side. And then if C is the midpoint of DB here, well, we've got our vertical angles. C is the midpoint of DB, then these are the same. And then if these lines are parallel with those arrows, using this as our transversal, we got some alternate interior angles with B and D. So triangle ABC is congruent to triangle EDC by angle, side, angle. All right, that concludes our video for this topic. Hopefully that went well.